This original IBM laptop had all the ports necessary for connecting EchoLink quite easily. It had, back in those days, all the ports needed. On the back here, it had one USB, when USB was first getting rolling. It also actually had microphone, line level, and audio out. As laptops started coming out after that T21 I just showed, you notice they've stripped off the serial port, still have a parallel port, and they added another USB port. They got rid of the line in, so now it's a mic in only jack. And it's still got the phone, telephone, modem, and the internet. And a mouse connection here. This is a T41. The other one was a T21. This only runs Windows XP. And you need this to build up a attenuator circuit here to drop it to mic level. So you're going line level to mic level. So you got to have that. Then, since the serial port's gone, you got to buy one of these USB to serial cables to get your handshaking for control of the EchoLink transmit and receive signals. And luckily, this laptop still has the audio in and out on it. But the newer ones have nothing. A newer laptop, you'd have to go with one of these sound cards that's USB. And also, you would still need to get the RS-232. So this would take up 2 USB ports. So needed to come up with a way to get all of this combined into one USB. So that's what this project is all about. So I want to do away with all this cabling and make a circuit that will take all of this signaling, audio, and the handshaking for EchoLink in and out of the laptop, the newer laptops that don't even have the audio anymore, inputs on it. That you would, on a newer laptop, you definitely have to put one of these dongles on there too to get the audio in and out. And this, again, is just mic input. So even if you use this, you still need the attenuation here because this is mic input only. So you'd still have to build an attenuator to drop the line level from a repeater into the audio card here. So that's an issue too. So yeah, I want to get rid of all this. So I'm going to design up a circuit that'll get rid of all of this stuff and make it easy to connect to a radio or a repeater. So that's the goal here. Doing some research for the ICs that I'll need for this project. First of all, I found a 3-port hub USB interface. 3 ports would be perfect for the EchoLink unit. 2 ports would be used, one for the audio, a second for the RS-232, and the third could be an auxiliary USB port. So I'm going to use this IC for the USB hub. I'm going to use this FTDI IC for the UART that'll be for the signaling portion of the EchoLink circuit. I've used this chip in other projects. It does work back to Windows XP up to Windows 11, so that should work out fine for the project. That's going to be the IC that is going to be for the UART of the circuit. I'm going to use the C-Media USB audio codec. This chip will give me the audio interface needed for the EchoLink, but it seems like most of these chips always have a microphone input. I wish it was line level, so I'll have to make an attenuator for that. And the output has a left and a right output, which I'll sum into mono. This will be the IC I use for the audio interface. I came up with a block diagram here for the circuits that I'm going to need. This will be the main USB port. 5-volt power for the EchoLink module will be taken from the USB port, fused, and then this will be the source for the power. I'll need both 5 volts, and then an LDO regulator will give me also a 3.3 volt. There's 3 ports to this USB hub. Port 1 will go to the FT230 USB UART. Port 2 will go to the USB codec. And port 3 will go to an auxiliary connector for an auxiliary USB port. Also, I'm going to tap off of the UART for logic level interface, and I also will be able to flip polarities of the signal coming in from a radio and the signal going out, so it could be active high or active low, switch selectable independently here. Then I'm going to have a max 3232, which is an RS-232 converter. That'll give an RS-232 output, so it'll actually have the serial output available, which really won't be used on EchoLink. What will be used is the RTS-CTS. So this will work the same way as the original RS-232 port to control EchoLink handshaking. All of that will be simulated here, but also there'll be a TTL level of the same type of interface. I labeled it radio COR, which would be a key of the EchoLink via the COR from the radio. And then from EchoLink, call it radio key. Those 2 signals are brought to both connectors. This connector will have the signaling and the audio both on this 5-pin DIN. Then we'll have level controls for the input. This audio mute will be for a future circuit I'll probably add to this to add some features. Because this has a microphone input, I had to attenuate by 25 dB this line level signal. Left out of the codec audio, I'm just summing. So I have a summing amp and an output level adjustment and a buffer amp, and that goes audio out to the radio or repeater or whatever it's connected to. Chances are this connector would be the best to use for the repeater or connecting to a radio, because it's all TTL level and line level audio. That's kind of the simple block diagram here. This is just a handshake polarity, a couple LEDs for EchoLink transmit, which is from radio out to EchoLink, and EchoLink receive if you're receiving signal from EchoLink out to the radio. I have switches here to handshake type, which will be logic level or RS-232 DTS RTS signaling. Going to have a selection there between the 2, and these 2 switches will be polarity for active low or active high signaling coming in from the radio and to the radio. That's kind of what I'm shooting for this EchoLink interface. This is page 1 of the schematic I've drawn up for the EchoLink system. This is the main port from the laptop or computer. We're deriving the 5 volts from the USB port. This is the TUSB 2036 3-port hub. I'm using a 48 megahertz ceramic oscillator to drive the clock on the chip. So we have DM1, DP1, which will go to the serial decoder. DM2 and DP2 will go to the audio chip, and we have an aux USB port here. So it's just an extra USB port extension from the computer. We also have a PROM here, just in case it's ever needed in the future. So all these buses are terminated to the spec here. This is page 1, and we got to go to page 2. Okay, this is page 2. From page 1, DP1, DM1 comes into the serial port decoder chip. The second USB port, DP2, DM2, goes to the audio chip. And on the other page, page 1, we had the third port going to the external or auxiliary USB port. I've added a microcontroller. Back on page 1, I'll go back to that shortly, is a touch-tone decoder. We're going to have touch-tone decoding take place on here to shut EchoLink on and off, and there's some auxiliary controlling. So we have an aux 1, and an aux 2 that'll come off the micro. That's just 2 open collectors that are used for auxiliary control of anything one would want to control. This is for active high, active low. Like I said in the original block diagram, sets the COR and the key polarities. Here we have the MAX 3232, which converts the serial data into RS-232 protocol. The micro generates a CW code when using DTMF. The codes that are decoded are 3-digit. This little filter here creates a sine wave of a CW code that is also mixed in with the audio that goes to the radio or repeater. So you get a CW OK if you've hit the right touchtone codes. And because EchoLink is constantly decoding DTMF, you need to suppress or mute the first digit of any code that's entered so it won't go out on EchoLink. So that's what this audio cut does down here. And this switch selects the first digit to be A, B, C, or D. So like A19 would be a code, for example. You can make it B19, C19, or D19 because sometimes these digits are used for other things. So you might want to select it to be something different than just A or B or C or D. So that's what this is for. You definitely have to mute the audio going to EchoLink or it'll just dial up anything or try to. So that's what that's for. And I also over here have a optional Vox module that'll plug in. So the audio has to be attenuated because you're using a mic in here. Then the outputs are summed. These op amps are rail to rail. They operate quite well at 5 volts. So we're using those for the audio chain here. And we have output level adjustment and input level adjustments. Everything's brought out on this DB9 plug here. And also the, I want to say TTL level, but the logic level and the audio are brought out on this 5-pin DIN. So that's pretty much it for page 2 here. Back to page 1. This is the DTMF decoder here, and its data goes over to the microcontroller. It's a MT88L70 decoder, and here's the low dropout power supply where the 5 volts comes in from the USB port and is dropped down to 3.3 volts. And off the 5 also generate a reference half V of 2.5 volts for the op amps. So everything should be ready to lay out on a printed circuit board. This is just a quick look at the updated block diagram showing some of the additions here. And these particular additions can be not populated for just EchoLink purposes only without any of the microcontroller and DTMF options. Okay, I have the PCB laid out here. It's going to be a 4-layer board. The green here is top layer, the red bottom layer, and the kind of aqua blue is power layer. The ground layer I've got turned off at the moment. It'll be kind of a small board. It's crammed on here pretty good. It's all 0603 caps and resistors to make it as small as I can still hand mount the parts, which will still take quite a few hours to hand mount these small resistors and capacitors. So this is the board, and show the ground layer, which is basically a ground plane throughout the whole board here. It's going to be time to send out for boards and see if I can get all these parts mounted on there. I received the boards and they come out pretty good. I'm going to build 3 of the prototypes here. I wrote a code for the processor and the DTMF decoder, and so got to load the code also once the board's built. We'll get things going here. See how mounting all of these parts goes. Okay, I have the boards built up. I'm going to start with the first one here. The front of the board has the USB input from computer. This is a USB 2 port. This will be the auxiliary port. I'm going to plug a mouse into that to control the computer. This is EchoLink receive, EchoLink transmit LEDs. Then on the back, this is the 5-pin DIN for audio and the logic control in and out to a repeater or radio. This has a few auxiliary pins plus the common pin 2 and pin 3 for RS-232, and also the pins for the RTS DTS control, which allows for original type controlling of EchoLink, just as if this was on the back of the computer itself. We have two adjustments, input level and output level audio to the radio or repeater, and there's a DTMF level here too. We have a dip switch here that sets the DTMF first digit code. This small switch here puts it in RS-232 or logic mode. For using it on logic, like to a repeater, you'd want this switch up. Down would be RS-232, which would make this the standard setup that was original for EchoLink using DTS RTS. And this switch sets the polarity of the logic ins and outs, whether active low or active high, coming from a repeater or a radio. That's all of the switches here and the options. This connector here is for a Vox board. You can put a Vox on here to key the EchoLink. So that's an option that'll go here. So it's time to run some tests. The computer is connected via the USB now. I earlier measured the 5-volt current, the main current out of the USB that the board is taking, and it's around 110 milliamps. So there's plenty of power available here from the USB port. I plugged the mouse, have a mouse plugged in to the spare port, which is working fine. Also, the red LED means during power up, the EchoLink is active. Okay, I'm going to try some DTMF codes here. I'm just going to turn the EchoLink access on and off. The red LED is access, which means the EchoLink is active. The audio path is active to EchoLink, and it comes on when the board is powered up, so it's always in EchoLink mode. However, it can shut it down by using touch tones here. You get the CWID code that the code was taken, and this LED here, the blue LED means there's no audio path to EchoLink, so it cannot decode any touch tones. And I can re-access it here. And it's back enabled. And also, whenever you hit whatever first digit this switch is selected to, right now it's on A, whenever you hit the A, you get a mute to EchoLink, so any touch tones you do here on the pad will not go out to EchoLink and create havoc out there. Now if I set this to B, it would mute B or C or D. So the first digit will always be one of these four here, depending on which one is selected. That way it'll mute, because if you hit any other codes, when you want to dial up an EchoLink station, they'll all pass through. So if you notice, there's no mute. So they'll pass right on through, so you can dial up a node. But if you want to control the microcontroller on this particular board, you have to mute the codes from going out to EchoLink. So that's why when you hit the A, it'll light this LED and mute for an amount of time it takes to hit in your code, and then it drops back out. Okay, I'm putting in 0 dB on the radio side of the EchoLink controller. I'm recording the signal as if it was at the EchoLink end of things here. Is recording at a -10. So when I go to play it back, it'll act as if it's coming from EchoLink. Okay, I'm playing back the signal now that I just recorded through the EchoLink controller. Coming out, we have a 0 dB. There's the sine wave on the oscilloscope. So the audio paths are working fine. And the green LED is blinking, which shows that the audio path is live. Okay, I'm going to loop back the radio COR and radio key, and it's set for active low right now. I have a COM port test program, and I can test the RTS DTS. I click in here, and you see it, the CTS does return. So as it's looped back, and the scope went low. So the signaling through the COM port is working fine also here. Now I put the S1, took it from radio and put it in RS-232. Instead of being logic out, it'll be RS-232 protocol. We'll still have the RxD, TXD control leads for EchoLink, but also added to that is a standard RxD, TXD. So I've looped them both back here to test the RS-232 protocol. RTS and DTS are still functioning fine. The RS-232 is looping back fine. So everything's working. So it's time to actually try it on EchoLink. Well, first I'm going to mount this in a project box here. And I got this pretty cheaply. It's about $9. And that'll house the EchoLink controller. Had to notch the back though because to get the DB9 in the box. So that wasn't that much fun, but all in all, I think it'll do good to hold the unit together, and we're ready to test it now. Okay, I have the controller mounted in a project box here, and it's connected to my repeater controller. The USB connects to this T41 laptop, and I have EchoLink running. Okay, got an HT here that will come up through the repeater down here into EchoLink. So I'm going to give it a shot. I'm just going to use the mouse here because it's a little easier to. So station. I'm going to connect to the test server.
Connected. Welcome to the EchoLink test server. This server records your transmissions and plays them back to help you adjust your transmitted and received audio. Please feel free to connect as often as you like.
And I got a courtesy tone in there too, set up. Testing 1 2 3 4 to the EchoLink server. Testing 1 2 3 4.
Testing 1 2 3 4 to the EchoLink server. Testing 1 2 3 4.
Okay, so it seems to be working. This HT is a little tinny sounding, but I do have a regular speaker down here I could push it through. So it seems to be working. This HT is a little tinny sounding, but I do have a regular speaker down here I could push it through. Okay, so the EchoLink controller seems to be working, and I got rid of all that cabling that went in and out of the computer. So now it's just a single USB port coming into the laptop. Things seem to be working as planned. Try a couple code tests. Try a couple DTMF codes here just to check out through the entire repeater and EchoLink and everything else. First I'm going to see if 09 actually brings up the last station I talked to, which was the EchoLink test. Okay, because I have EchoLink disabled, so I'll enable EchoLink, and I got the first digit set for D. So I got the OK. So we'll see if EchoLink comes up.
Connecting to conference ECHOTEST. Connected. Welcome to the EchoLink test server. This server records your transmissions and plays them back to help you adjust your transmitted and received audio. Please feel free to connect as often as you like.
Okay, testing 1 2 3 4.
Okay, testing 1 2 3 4.
Yeah, I might bring the audio coming back up a little bit, or going out I should say. Bring that audio up a little bit. Okay, we'll dump it.
Conference ECHOTEST disconnected.
Okay, so the controller seems to be working fine, and I'm rid of all those extra cables I used to have to connect up for EchoLink. Right now I'm just using the direct logic out port because I'm connecting this to a repeater. So audio out, audio in and out, and radio or repeater COR and radio key or repeater key, whichever you got it hooked to. I'm using that port. I'm not using this port at the moment, but I could use this because I have those extra open drain transistors here for DTMF control of any auxiliary things you might want to control on the output, but that's just an extra I added. So anyway, everything's working fine. So next will be come up with the Vox circuit.